Hello and welcome to the Chanda Academy. In today's video, we are going to study a logarithm function. First, we want to find the domain of the function f defined as such, then solve the equation f of x is equal to 1, and finally show that this function is what we call an odd function, which means that f of minus x is equal to minus f of x. Let's start with the first one. We know that a logarithm function is defined when what's inside is of course defined and when what's inside is greater strictly than 0. So let's call what's inside g of x and study this side function g of x. So g of x is the function that given x gives back x plus 2 over 2 minus x. So this is really more convenient to say 2 plus x over 2 minus x. This function is a rational function. This is a quotient function, very easy to study because we can study the numerator and the denominator separately. So 2 plus x is greater than 0 is equivalent to x greater than minus 2. 2 minus x greater than 0 equivalent to 2 greater than x. So x lower than 2, which means that this function, so this is the first thing. Then we don't want, obviously, this function to have a denominator equal to 0 because dividing by 0 is forbidden. And we will say that just after. So let's study the function. We've got the first function 2 plus x. So the x-axis in the table of sign going from minus the infinity to plus the infinity. We've got 2 of x, we've got 2 minus x, and finally we've got g of x, which is equal to 2 plus x over 2 minus x. The important values will be minus 2 and 2. In minus 2, we will have 2 plus x that is equal to 0. And we will, in 2, we will have 2 minus x equal to 0. Because 2 minus x is a denominator, when we divide by 0, this is a forbidden value. And so the function g of x is not defined. When this is 2 plus x that is equal to 0, we've got our function g of x equal to 0. Then what happens before minus 2 for 2 of x? Before minus 2, 2 plus x is negative. After minus 2, this is positive. This is the other way around for 2 minus x, because when we've got x lower than 2, we've got this function that is positive. And after, this is negative. For the function g of x, we can divide the signs. Here we've got a minus, here we've got a plus. Minus times plus is equal to minus. Plus times plus is equal to plus. And plus times minus is equal to minus. And here we can see that we want at the same time g of x defined and greater than 0 strictly. And so our solution will be this interval here. This interval here. So g of x is defined and greater strictly than 0 when x, so if and only if we've got x between, so let's look at our graph, minus 2 excluded and 2 excluded. Minus 2 excluded and 2 excluded. And this thing here will be our domain of definition of f. This implies that f is defined if and only if x in minus 2, 2. And so the domain of definition, df of the function f, is equal to minus 2, 2, without the border values. And we have solved our first question. Now, second question, we want to find the solution. So find the solutions, maybe multiple solution of f of x is equal to 1. Let's rewrite f of x as logarithm of 2 plus x over 2 minus x is equal to 1. We know that for any logarithm, logarithm in base a of y of x is equal to 1 is equivalent to y of x being equal to the base of the logarithm. Here, the logarithm without anything is a logarithm in base 10. In base 10. And so this equation is equivalent to 2 plus x over 2 minus x being equal to 1. And now we can multiply, because this thing is not equal to 0, we can multiply on both sides by 2 minus x. We've got 2 plus x is equal to, well, this is a 10 here, okay, this 10, to 10 times 2 minus x. Developing the right side, we've got 2 plus x is equal to 20 minus 10x. We can put the 2 on this side and the 10x on the other side, and we've got 11x, so 10 plus 1x is equal to 20 minus 2, which is equal to 18. And this is equivalent to x is equal to 18 over 11. Now we can say that 1 is equal to 11 out of 11, and that we've got x greater than that, strictly, because we've got 18 over x. And this thing is lower than 22 over 11, which is equal to 2. And we can say that x is between 1 and 2. And so let's call x0 this solution, okay? So x0. And this is a good thing because being between 1 and 2 allows us to be in the domain of definition of f. And so we do have x0 is equal to 18 over 11. Solution of f of x is equal 1 and in df. And this implies that x0 is equal to 18 over 11 is the solution. Perfect. And now lastly we want to prove, so little 3, we want to prove that for all x in df, f of x of minus x, sorry, is equal to minus f of x. Okay, this starts well because we've got our 0 here, our x-axis here. We know that we are defined between minus 2 and 2, excluded both, and so that every minus x has a x in the domain of definition, okay? And this is a very good start. So here, this minus x has this x, etc., etc. And if my x is negative, here I still have an x in the domain of definition on the other side of 0. So perfect. Now let's compute f of minus x. Okay, so for all x in df, f of minus x is equal to what? This is equal to log of 2 plus minus x over what? Over 2 minus x. Perfect. We develop. This is equivalent to f of minus x being equal to log of 2 minus x over 2 plus x, and this thing is equivalent to f of minus x being equal to log of 1 over 2 plus x, 2 minus x, and we know that log of 1 over a is equal to minus log of a, and this thing will be equivalent to f of minus x being equal to minus log of 2 plus x over 2 minus x, which is this thing here. And we recognize here f of x. And so this is equivalent to f of minus x being equal to minus, because we've got the minus here still, minus f of x. And we have proved what we wanted to prove. Hope you enjoyed the video. See you soon. Bye.